Predicting the products of these combination reactions, it can be a little bit challenging. So we have our general form where two things come together to form one thing. But then you can classify it into other types of combination reactions, and they have these patterns. So you got to learn the patterns. These are the main ones you need to know. And what's nice is the reverse is decomposition. So you're going to learn that at the same time. We'll wrap up with a brief assessment just to make sure you got it. If you'd like to take my full course on predicting the products of chemical reactions, all different types, go to my channel page and then go to the Courses tab and you'll find it there. So the first category is binary, and this is mostly what you're going to see as a general chemistry student. We have two different elements together like NaCl or MgBr2 or something like H2 and O2. So essentially, these two come together to form one thing, Na and Cl. The Na joins with the Cl to form NaCl. Pretty simple, right? But because we have a metal and a nonmetal, we have to check the charge. So let's go to the periodic table. In group 1, here's Na. So all of these are 1 plus, group 2, 2 plus, skip the transition metals, 3 plus, 4 plus, 4 minus, 3 minus, 2 minus, 1 minus. There's our Cl right there. So sodium is 1 plus when it forms ions, and chlorine forms 1 minus ions. So we need to know that. Since you have 1 plus and 1 minus, those charges cancel out. So we're good with just NaCl. Note that in this video, I'm not going to actually balance the equations though, and I'm not going to write the states. You don't really need to do that to predict the products. But if your teacher wants you to, you got to do it. Let's look at H2 plus O2. So it looks like we should just have HO. But this is one where we have two nonmetals coming together. It might be difficult to predict, but for this particular reaction, H2 plus O2, that gives water, probably one you want to memorize. If we look at S plus O2, sulfur plus oxygen gas, it's a little more complicated. Do we get SO2 or do we get SO3? Both are pretty common compounds. The answer is you just can't tell from this information. You'd have to be given information about catalysts or temperature or pressure, and we don't have that here. So typically in general chemistry, if I saw this here, I'd say SO2 if the teacher didn't give me any more information. Usually you won't have this type of problem, and if you do, the teacher will tell you, know that S plus O2 gives you whatever it is at those conditions. But for these other ones up here, you can do those. Let's take a look at another type. For the carbonates, you can see M, that's the metal, then we have the oxygen right here, then we just have CO2. This is the CO2. So it should give us M, we said that was the metal, and then CO3. So we end up with CaO plus CO2, that combines to form calcium carbonate. Not too bad. So pause, give this one a try. So in the products, we have the metal, that's the Na, and then we just have CO3. But we do have a problem here. Remember we said sodium, that's 1 plus. It turns out the carbonate ion, the whole thing is always 2 minus, just something you have to memorize. So if we have a 2 minus here and a 1 plus here, charges don't balance. We really need 2 of these sodiums for this to work. So in the combination reaction here, since we have a metal and some nonmetals, it's ionic. Got to make those charges balance. If you need help with that, there's a link in the description on how to do that. All right, carbonates, that's the pattern. Let's try hydroxides. This is a pretty simple pattern too. We end up with the metal and the OH. And OH, that's the hydroxide. That has a 1 minus ionic charge. Always does. Got to memorize it. So we should end up with just Na, that's our metal, OH. But we got a metal and nonmetals with these hydroxides. We do need to check the charges. So we said this whole thing here, the hydroxide's 1 minus. We know the sodium's 1 plus. It's all good. Pause, give this one a try. And know that magnesium, that forms 2 plus ions. So we have our metal, that's the magnesium, and then we have the OH. But remember, the whole OH is 1 minus. Magnesium, that's 2 plus. So we need to have 2 of these for this to work. So we end up with MgOH2. Let's get rid of that. as the correct answer for the combination of MgO plus H2O. Let's look at our last category, the oxides, metal oxides. So for our metal oxides, we have a metal plus oxygen gives us a metal oxide. So K plus O2, that just gives us KO. But remember, oxygen's at 2 minus, potassium's at 1 plus, so we do need 2 potassium atoms to balance that charge. That's what we end up with. Pause, give this one a try. So we should end up with MgO, like this. But remember, we always want to check the charge. And magnesium group 2, that's 2 plus. We know oxygen is 2 minus. It's all good, those balance out. All right, let's lock that knowledge in of these combination reactions with some practice. And if you need help, you can go back into the video and see where you're having problems. You'll need this too. So that's it for these combination reactions. If you can do these, you'll be in really good shape, and decomposition reactions will be a lot easier as well. They're just the reverse. This is Dr. B, and thanks for watching.